Okay. Good afternoon, everyone, and thank you very much for staying for the last presentation. We'll try to move away from the theoretical discussions earlier and focus on data. So we'll try to find out, what data tells us about, what lowering the inflation target would bring to the South African economy. So this is a joint work with Kea, who is here, Kea from the National Treasury. And as usual, the disclaimer, so the usual disclaimer applies. So only all accountable, myself and Kea for everything we're going to talk about here. Thank you. So a quick overview, but yeah, let's get started straight. So we know that all around the world, inflation targeting has become kind of like the preferred monetary policy implementation framework for many central banks, both from emerging economies as well as developed economies. And we know that its price stabilization benefits are very well documented out there across the literature. So, however, while an important strand of the literature suggests that the optimal inflation rate should be near zero, some central banks, mostly in developed economies, have targeted around 2% inflation. So meanwhile, emerging economies that adopted the inflation target framework, initially they've targeted higher targets, but then they gradually shifted towards lower ones. So, however, we know that the macro effects of lowering the target, mostly in those emerging economies, receive less attention. There are a lot of work done out there for the US or the EU area, or Japan, for instance, but little or no work has been done for emerging economies. So, and this paper aims actually to fill this gap by estimating the dynamic effects of shifting to a lower target for South Africa, and also because, indeed, we want to contribute to the debate, according to which the central banks has made public calls of its desire to lower the target from the 3-6% range to a point target of 3%. So what we do here, we investigate the macro effects of shifting to a low inflation target for South Africa, and we do so using the market identification strategy that helps us identify inflation target shocks in a structural VAR model, and then we estimate the impacts of these shocks using Bayesian methods. So, and in our estimation, we use quarterly data over 2003 Q3 to 2024 Q3, so that was the last observation available, so based on the BER survey. And indeed, this sample includes the highly volatile COVID-19 period, and we'll try to account for that in our estimation strategy. And finally, we estimate the model using Bayesian techniques and in a Markov chain Monte Carlo Gibbs sampler. So what do we find? So first, we find that a decrease of 1 percentage point, so in the inflation targets, would lead to output expanding over the next few quarters after an initial muted response, and with a peak of about 1.2% after about 2 years, and it would remain positive and statistically significant for about 3 years after the initial shock. And we also observe a short and medium-term movement of inflation and the nominal policy rate in response to the target shock. And this is actually reminiscent of neo-Fisherian effects. But importantly, what we've noticed is that unlike most of the findings out there in the empirical literature directed towards developed economies, the effects of the inflation target shock in the case of South Africa is quite less persistent. So we find that indeed they're less persistent, and this might have some implication, among others, that that often cited gain linked with permanently lower and permanent lower borrowing cost, due to lowering the target might not apply to South Africa. And finally, we've tried to understand through which channels the target shock might propagate to the economy. And we found a strongly operative sovereign credit risk channel as well as asset price channel. Actually, as Viegi and Katarina found in their work as well. So a brief kind of like overview of the literature. Basically, we have three main big categories. So we've looked mostly, because we were mostly interested in an empirical work, so we start to look at the empirical literature out there. And we are building up in Mumtaz and Theodoridis. So, and basically what characterizes the approach is that the inflation target shock is a survey-based measure of inflation expectations that they use in the estimation. Unlike Lukmanova and Rabic, who use basically kind of like the estimate the inflation target based on some DSG models from which the estimate implied target, and that and indeed in a new Keynesian setting. And finally, we have some other group out there in the empirical literature. They make use of co-inflation measures, and where they have both nominal and real variables along with the co-inflation measure, and they estimate the shock using long-run restrictions for Micheli and Iacoviello, or some form of co-integration for Uribe. Now, a second group of the literature is the theoretical DSG literature. Now, I guess we can add the two papers presented earlier, but along with them, we have like a few references that I'm providing here. So, and finally, for the literature applied to emerging economies, so I would likely mostly want to point the work by Nicola and Katrina, where they also look at how moving from kind of like the midpoint target at how the Reserve Bank moving from kind of like, reducing the target from the midpoint of 4.5%, so has affected the economy. And they mostly found that, it has led to kind of like non-negative output growth and driven by, again, asset prices and sovereign credit risk. So the talk itself is outlined as follows. I'll quickly take you guys through the empirical strategy and then our baseline results and some robustness analysis before kind of like discussing a bit the transmission channels. So, so basically identification. So the way we think about it, and following mostly Mumtaz and Theodoridis, so we think that the long-run inflation expectation it's driven mainly by shocks to, indeed, the central bank's inflation target itself, but also a range of additional shocks, including technology, policy, and non-policy aggregate demand shocks. So, but we know that over the medium to long-run horizon, so the contribution basically of the central bank's inflation target would be higher in relative terms compared to the other shocks in the economy. And specifically, if like the central banks react systematically to changes in inflation, and like a strict inflation targeter, and it also perceived as being credible, at least in the long run. So then we assume that long-run inflation expectation would coincide with the inflation target. So that meaning that we have like inflation expectation anchoring in the long term. So, and then as a consequence, any further changes in long-run horizon inflation expectation would simply reflect shocks to the inflation target. So, and this is, how to illustrate it in the context of South Africa with the data. So here we have like different measures of inflation expectations from the BER survey, 1 year ahead, 2 years, 5 years ahead, along with the core measure of CPI inflation, and overlaid by the range, so the 3 to 6% inflation target range of the SAP. So we can clearly see that there are two distinct periods up here. So from 2000 to around 2010, we have like high volatile, high volatility in the different figures reported here, and then from 2010 onward, So we can notice that we have like a better anchoring of inflation expectations. So as you know, they tend to be mostly within within the range. So the band here. So, and basically, we also check out there, so to try and interpret what's going on here, we've checked that basically out there in the literature in South Africa already, mostly from some work by Nicola and Coco. So, that try to explain, through central bank communications and forward guidance that, that these are things that have helped improve basically the anchoring of inflation expectations over time, mostly in the second period that we're looking at. And some other explanations by Kabundi and some co-authors, so they found that basically inflation has become less persistent, over that second period. So now this brings us to, continuing with our identification strategy. Basically, earlier we've provided like some form of evidence that, there's a feeling that, central bank credibility in South Africa has improved over time. So now, in our estimation strategy, we use the following VAR model, where Y stands for actually Y study, yes, the vector of endogenous variables, including indeed a measure of long-run inflation expectations, along with other, endogenous variables that I will make clear soon. And here in our identification strategy, so along with the mark share identification, so for simplicity, we order our inflation, our inflation target variable first, and before the other variables. Here, alpha stands for the vector of intercept, and P the lag length. So, and epsilon here denotes basically the orthogonal or structural shocks, A0 being the contemporaneous impact matrix, such that so A0 times A0 prime is sigma. And finally, indeed, we know that E0, so in such settings are not uniquely, determined and can span, and the space actually that is spanned by those matrices can be represented as A0 tilde F times Q, where Q is an orthonormal rotation matrix. So now when we rewrite the reduced form equation in structural moving average form, then we can get to the equation 3, so which allows us to have to define the k period ahead forecast 0 of the f variable here. And here again, because we have ordered our variable of interest first, so E1 here is the selection vector that would pick up our long-run inflation expectation in the set of our variables. And the shock would then be identified again as the one that makes the largest contribution to the forecast 0 variance of the long-run inflation expectations. So, and then indeed we can, because we're using a max share identification strategy, we can write down our maximization problem, solve for it, and and get our solution, which can it's an engine value vector problem. So we will have the solution in the equation. The question is not, but S here, where SQ1 equal lambda times Q1, where S is defined as below. And this is, again, the definition of the engine value decomposition, with the solution Q1 being the engine vector of S, which is associated with that largest engine value lambda. So now for the data themselves included and the variables included in the model. So indeed, on top of our BR long-run inflation expectation, we have also GDP, real GDP, which enters the model in log level, along with the end of period analyzed CPI inflation, the 10-year bond yield for our long-term real interest rate, and so the end of period repo rate R, which is the SVAR policy rate here. So, and we use actually here the BR 2 years ahead expected inflation as our benchmark, for long-run inflation expectations, and the data on the period, as I mentioned before, and we use a lag length of 4. And ideally, indeed, we would have preferred a longer, a longer horizon inflation expectation variable, but the only data we found for it, so the 5 years BER ahead inflation expectation, they only started in 2011 Q3. But we show that basically both the BER, the 2 years and the 5 years ahead inflation expectations are quite highly correlated. So we think we're good out there with the 2 years inflation expectation variable. So quickly, the estimation strategy, basically, we estimate the reduced form VAR in equation 2 showed earlier using a Bayesian approach and a Markov-Chain Monte Carlo gauge sampler to help us approximate the posterior distribution of the parameters. So, and in particular, so what we do, so we use Minnesota prior along with the natural conjugate distribution, and this prior indeed incorporates the belief that, the more recent lags should provide more reliable information than the more distant ones, and also that own lags should explain more of the variation of a given variable than the lags of other variables in the equations. And so hence, our prior, so the prior mean for each endogenous variable in our model will be derived using an OLS estimate of an AR1 process, so for the first lag, but also and the sum of the lag-dependent variables, and we'll do so using a training sample. And the prior tightness parameter in this type of setting, so we will set it just close to standard values out there in the literature. And finally, to control for the extreme observations that we've seen during the COVID era, so we follow Cascil Gracia, so 2014, in a paper where so he proposed how to kind of like someone can extend the prior with time dummies in order to kind of like account for these unusually high volatile observations, so in the estimation and identification scheme. So and then given the conjugate prior, then we simulate the conditional posterior of our model, so using the GIF sampling algorithm. So now the results. So these are our baseline results where kind of like we look at how lowering the inflation target by 1 percentage point would affect the variable included in the model. So here, so if we think we assume that the central bank decide to lower the target by 1 percentage point, so that would lead to the long horizon inflation expectation kind of like, going down, indeed, becoming negative and persistent over about 11 quarters before reverting to zero, and it reaches a through of about 1.2% after, say, about 3 quarters. So, and indeed, as one would expect, so when you lower inflation target, so actual inflation, along with the repo rate, goes down, as can be seen here on the graph. And let's see. Okay, it does work. So, yeah, on the graph here. And interestingly, one will notice that both moves hand to hand, like both in the short term and the medium term. And this is basically reminiscent of those neo-Fisherian effects I mentioned earlier. And other works in the literature, including those by Mumtaz and Theodorodis, but also Lukmanova and co-author. So they found similar patterns. And so now, interestingly here in our case, basically due to nominal frictions in the short run, the inflation, actual inflation, decreases more than the repo rate, which leads indeed to an increase in the real rate here. So for about a year, and so, but and this indeed, as a consequence, real GDP has a muted response for kind of like it's not significantly different from zero, even though it's slightly below zero, but for about a year before kind of like eventually expanding over the few next quarters. And yeah, so basically, and this basically the fact that the real GDP kind of like has a muted response and then increases in line both with some results that Uribe presented in his 2022 paper, and also in line with the non-negative output response that Nicola and Katarina also find in their work. And finally, we see that the long-term interest rate kind of like on impact decreases, but it's short-lived before reverting to zero. So now for a few robustness analysis, we started because we kind of like are performing a partial identification here. So we thought that we need to kind of like convince our audiences better about the shock that we identified, that is like truly or at least close enough to the inflation target shock. So what we do, we kind of like we compute bivariate correlations of our structural inflation target shock with other structural shocks identified in the literature as being kind of like important for the South African economy. So including all the shocks mentioned here. So uncertainty, all shocks, aggregate demand, exchange rate, etc. So as one can see, so the correlations are quite small. So around zero, as with the bands down there, up there, as you can see. So clearly suggesting that our shock, even though we're using a partial identification strategy, our shock is clearly not to be confused with all those other shocks out there. So, and finally, for the transmission channels analysis, I will focus only here on two transmission channels that we found to be operative, following the target shock. So, starting with the interest rate and other price channel. So, basically, what we see here is that following the target shock, following the target shock, basically, so we've got an increase in asset prices, basically, so stock prices and house prices, and this explanation to us, despite actually an initial increase in the real interest rate. So our explanation for that is basically because we think that following the announcement by central bank to lower the target, so indeed expectation of long-term inflation is kind of like we see that is persistent, and investors and consumers as well. So kind of like they perceive it as good news, and it encourages them to kind of like demand more assets. So. Leading to the increase in the asset values, and with the increase in the asset values, indeed, investment and consumption expenditure also increases. And as we can see down here for those two variables, we will also notice that there like a small muted investment response, which is kind of like similar to what we observe for output, and which made us kind of like believe that there might also be a direct interest rate channel here working like through, like say, the cost of capital channel, for instance. So, and for the second channel that we're looking at, so the sovereign risk premium channel, so we kind of like, mostly through this channel, we are looking mostly at debt to GDP ratio, credit default swap, and the real mortgage loan, so as our main variables in these channels. And following the lowering of the target, so debt to GDP indeed goes down after an initial jump over zero, sorry. And this leads, this leads to kind of like credit, indeed with the debt to GDP ratio going down. So the credit default swap also responds negatively, as one would expect. So, and our interpretation of this indeed is that the sovereign, lowering the target will lead to a reduction in the sovereign risk premium of South Africa. And that would indeed result in commercial banks being able to extend more credits out there. So to kind of like in this specific case for instance mortgage loans. And this result, as well as the previous one for the asset price channel, are actually in line with findings in the papers by Nicola and Katrina, where they also found that both the asset price channel as well as the sovereign credit risk channels are kind of like can help explain why output do not go down following that basically that sacrifice ratio that has been kind of like well known out there. So that might explain why we have that muted response of output in our case before it goes up. So quickly to wrap up, we found that lowering the South African inflation target will lead to output growing over a certain period, driven mostly by aggregate demand and a co-movement of inflation and the repo rate akin to neo-Fisherian effects. A feature, indeed, as I mentioned earlier, have already also been evidenced in other similar studies. And also, the inflation target shock substantially contributes to fluctuations of mostly both actual inflation and the policy rate. But its effects are less persistent, as for the case of South Africa, as I explained earlier. And finally, an analysis of the transmission mechanism of the target shock to the economy, reveals that there's a strongly operative sovereign credit risk as well as asset price channels. So that's mostly what I had to say, and thank you very much for your attention.